All right, in this video, I'm going to go through lesson 4, electrical schematics and wiring schemes. If you want, you can just read these paragraphs and look through the diagrams on your own and skip the video. Otherwise, I will just be going through the content here in the slides. So what we're going to talk about when working with electrical schematics is that we can look in the schematic itself. We can see right here this PK-14, 14 gauge wire. PK means the color. So if your manufacturer has made a colored harness, they will designate that color for each wire in the schematic. And so you will run into manufacturers that do not have colored harnesses. They're all white. They will not have color codes, and if they do, they're just going to be the white color code. But otherwise, manufacturers that color their harnesses will state it, and they're always an abbreviation for the color, and we can see the list of colors right here. This isn't an exhaustive list of colors, but what you can see from the 2-letter abbreviation is that it makes sense. Gray, GY, white, WH, pink, PK. So that's what you're going to look for, and so those 2-letter codes represent the color, and they're often drawn either in line with the wire. So this isn't a break in the wire, it's just saying this wire is this ID, or it'll be slightly above, just above the wire, so you'll be able to identify it. So if we take a look over here, we see an atmospheric pressure sensor and an engine oil pressure sensor. Something to be aware of with color codes. We see an orange, yellow, green. Orange, yellow, green. These two sensors have the same 3 wire colors going in. They're 18 gauge wires. Well, one thing to be aware of is at the connection, at the plug, these would be a Deutz plug, we can see that it goes to orange, brown, and gray. So this can be rather confusing. If you see the tail of the sensor is green, and you think back at the controller, it's also going to be green, but instead it's actually going to be gray. Same with this yellow, turns to brown. This can happen at any connection, quick connect in a harness. And so whenever the wire color is changed, whenever the wire code is changed, even the numbers right here can also be changed at the quick connects. Anytime it's changed in real life, it'll be represented in the schematic. So that's something to keep your eye out for. Otherwise, the colors are listed right here. If you see a color that, or a wire that's designated instead of 2 letters with 4 with a slash, this is blue/red. The red after the slash is going to be the tracer. That means the little colored line on the wire. And so this is really common in large harnesses so that they can take these standard colors and they can make a 120 wire harness and not have redundant colors. They just have blue with a red or red with a blue. And so you'd see how we could create so many different combinations of wires. One thing to be aware of when working with schematics is sometimes the manufacturer, these are quite nice, they're nice schematics, but they can be confusing if you're not familiar with them, is they will color the wire, so the wire line is actually colored. In this case, we see right here that we have a pink, a black, and a purple. Same purple and black, pink, black, purple right there. And you might quickly look at the schematic and say, oh, I'm looking for a pink or purple wire, but you're not. You're actually looking for a white, a green, and a gray wire. And so the color code is more important than the color on the schematic itself. And if you have a colored schematic, those colors actually represent different voltages, either when power is present or where the power is coming from or what circuit it's part of. And so we can see anytime in this is a CAT C15 schematic, anytime that we see that it's going to be a black wire, it's going to be part of the ground circuit. Anytime it's colored red, it's going to be part of the always on or constant power circuits. Blue is going to be ignition power. Orange is going to be starting circuit. You get the idea. And so it's important for you to look for the legend in the schematic to understand where those colors are coming from. All right, so then once we're done with color, let's look at the schematic wire labels. So these wire labels are manufacturer specific for the most part, except because that has led to confusion SAE has created a standard wire numbering system. J2191 is the code. You can go onto SAE's webpage, you can buy the code and download it, and you'll have the list of those. We've done that for our Foothills Techs. We have that list for our Class 8 vehicles. But what that means is that there's going to be a hashtag or a number symbol and then a 4-digit number following that separator. So we're going to see that symbol, and then we're going to see 4 digits. And those 4 digits correspond to a code in the SAE list. And so if you're not familiar with that list or you don't have it, you may be able to gain access to the manufacturer's code system, and that's going to be anything before the number symbol right here. And so in this case, this is the CAT schematic. We see that those are the numbers 325-AG135, where the AG is going to be the designation for what harness, and then we're going to see the wire group, which is going to be connected to a system, and then wire particular 135. And if you have the schematic, you'll have the legend where all these numbers are explained to you. But otherwise, if you don't have that schematic and you do gain access to the J2191 from SAE, you'd be able to use the 4 digits after the manufacturer's number to get an idea of where that code is supposed to be, or where that wire is supposed to be serving the system. Most manufacturers followed the previous SAE 2191 designations that had the systems being labeled with the first letter of the wire number. And so it may have an A218. Well, A would have meant that it was braking or traction system. Or if it was G218, G would have meant that it was part of the HVAC system. Or if it was an N, let's say N218, then it was part of the transmission and drivetrain system. And the 218 would simply be whatever circuit was. So we wouldn't have each system having the same wire numbers. We would have power supplied in the charging circuit or in the HVAC system or in the trailer system. But either way, with those numbering systems, you're going to need the manufacturer's breakdown of what they used those codes for. But when we use these schematics, what's really important for us to keep in mind is that function is more important than wire color. Because we all service equipment that's had a service life, it's a chance that the wire has been replaced, it's been repaired, and the wire color has changed. What's more important is that the pin location remains the same. So this is particularly troublesome when we deal with trailer wiring, either the 7-pin blade or the 7-pin round. Often the wire is replaced with somebody else's wire. Somebody needed to make a repair. They didn't have a green wire, so instead they used a black wire or a brown wire or a yellow wire. And now what we have is 2 yellows. So your job as a technician is to understand what the terminal location is supposed to be for, which is what the schematic will tell you, and then make sure it actually gets routed to the right device. So you're going to have to use a resistance-based test or a test light to check the function of the terminal, and then find the device that matches that function and make sure those wires are connected. It's nice if you're performing a repair if you can return the color back to the right color, but if you don't have that available and you need to perform the repair, just make sure the terminals are put in the right place. Now, all of these symbols that get used in schematics can be quite challenging, and the reason for that is we have multiple systems working here. We have NEMA, which is an industrial and automation schematic system. We have SAE, which is going to be for transportation, and we also have an ISO, International Standards Organization. So we're going to see that manufacturers use a combination of these depending on where their engineering department was based and depending on what industry they primarily work in. Companies like Eaton and Cummins have both a foot in the transportation world as well as the industrial application because they create power systems that work in electric power generation. And so you're going to find that the schematics can sometimes be confusing which symbol they used in which schematic. And so what we're going to see here is a legend, and this one's from the Mitchell 1 Truck Series online service manual. And there's a tab in there that says Understanding Mitchell schematics. And what we see is a breakdown of each one of the symbols saying, oh, this would be a fuse. So if you see this symbol, it means a fuse. If you see this squiggly line, but it's not sharp triangles like this one, it's this one, then that's an intentional heater element. This one over here is a resistor you may find in a relay to prevent arcing at the switch. Or you might find a clamping diode. That would be one over here in the relay the same way. Another thing you'll see is all the different switch positions, right? So you have a single pole, one circuit, and this one has two throws, two electrical positions. A single throw, or a single pole, three throw right here. And so we see these combinations explaining that each one of these black dots is a circuit or a leg of the single circuit that's being controlled. So it's really helpful because not all of us can remember what the schematic symbols mean, and we can get quite confused. It's really helpful for you to find the legend in the schematic, and if it's a digital schematic, it'll still be available in the digital system. And when you find that, look up what that symbol means so you're not making an assumption, you're actually working with good information. So now that we've talked about color, we've talked about code, and we've talked about symbols, one of the things that are most helpful when you're learning how to read schematics is to get the whole picture. If you have a big enough monitor, it's relatively easy to see a big picture of the schematic. Besides that, it's really small. And most of you are working with technician laptops that have 12 or 13-inch monitors, and so it's even harder to see a full schematic image. So you have a few options. One, you can get used to using the hotkeys that are in your schematic system. So we've listed a couple down here. Hitting Control on your keyboard and the F key pops up a control find. If you put a keyword in, let's say the name of your sensor you were looking for, if that sensor is listed in the schematic, it will find it. So that's quite helpful, especially if we're working online and you're using a PDF version of a schematic. If you want to see the full picture of the schematic, I have two versions here in image in front of us. And on the right side, we have a large print format. So what that means is we took an image, a PDF, a copy of that schematic, we downloaded it, put it on a thumb drive, I went to Staples, got it printed, and now we have a large format version of this schematic that we can work with, which is really great. We can trace wires from sensor to pin location on the ECM. We can use a highlighter on it. We can use markers on it. We can make comments. If you're doing your voltage drop checks, you can actually write expected voltages on here. And so there's a lot of pluses to using a hard copy schematic. On the left, this is a taped together Mitchell Truck Series schematic. So this was 9 pages, trimmed off the edges of the page so that we could get these wires as close as we could to each other. You can see the little tape mark right there. And so this schematic turned out to be 5 feet long, but all the ECM connections are there. All the sensor and device connections are there, so we can see their pin locations, and we would be able to trace them back to their pin location of the ECM. Again, a hard copy schematic is very helpful, and it allows you to trace the wire with a highlighter so that you can see where it goes, what pins it's going to be connected to. And once you've done that, then you can create your test plan to know where you should have voltage, where you shouldn't have voltage, and you can go and perform that test and compare it against the notes you made on your hard copy schematic. So while it's not always practical to do it quick, and it's faster ultimately to learn to use the online schematic, when you're doing a serious diag, it can be really, really helpful to be able to come back to a hard copy, trace your wire, write on the schematic what you expect to see, go perform that test, make a comparison against what you expected, and try and be able to make a diagnosis because of that. So while digital schematics have come a long way, they do require a lot of practice for you to get better at them. And so if you're learning to read schematics, it may be helpful for you just to start out with printing them. All right, this has been Lesson 4, Electrical Schematics and Wiring Schemes.